Okay, guys, here's the part 4. We have 6 parts, you guys, so of our review for our semester final, second semester final for IM2. Okay, so here's a proof right here. Hopefully you can see that. So given that these lines are parallel and these lines are parallel, we want to prove that angle 6 is congruent to angle 10. So what I'm first going to do is put this second given down, that these lines are parallel, okay, and then I'll mark them, okay, marking them with the arrows right there. Okay, with these parallel lines, all right, now remember we got to get 6 in the picture and 10 in the picture. So I'm going to say there's other ways to do this, you guys, but I'm going to say you could do these guys are parallel also. I'm going to say 6 is congruent to 14 because they're corresponding angles, and if the lines are parallel, then corresponding angles are congruent. Okay, and then the next given goes down, so the top and bottom are parallel, and then I'm going to say that 14 and 10, and notice now 10's in the picture. We got 6 in the picture, now 10's in the picture because corresponding angles are congruent, okay? And then if 6 equals 14 and 14 equals 10 right there, then 6 must equal 10 by the transitive property. Okay, there's other ways to do it. We could have done from the top and bottom parallels. We could have said 6 is congruent to 2, and then we could have said 2 is congruent to 10, and then therefore 6 is congruent to 10. That would have worked also. Okay, all right, so here we have the top and bottom are parallel, so C is parallel to D. And then we have angle 1 is congruent to angle 2. We want to prove that these guys are parallel. Okay, so let's put the first given down, the parallel lines. All right, and then these guys are, for the same reason as the last proof, are corresponding angles, so they're equal because the lines are parallel. Okay, and then now let's put this next given down. Angle 1 is congruent to angle 2 right there. Okay, now look at this, you guys. It says 1 is congruent to 3 and 1 is congruent to 2. This one is not a transitive property because the second part of this guy has to be the beginning part of this guy. Let's go back to that last proof real quick, you guys. So notice how this second part of this one is the first part of this one. So if it does a zigzag, a Z sort of shape thing, that is a transitive property, whereas this one is not, because 3 does not go here. So 1 is congruent to 3, 1 is congruent to 2. So we can say that these guys are congruent, but that one is just substitution property, okay? 2 is congruent to 3, okay? And what we did is we substituted this 2 in for this 1 right here, okay? Because 2 is congruent to 1, so we just substituted 2 in for that one right there. All right, now look, these guys are corresponding angles, and if corresponding angles are congruent, then the lines are parallel, okay? All right. So with the write an equation of the circle in standard form that has the center, remember center is HK, 2, -3, and radius 4, then graph. Okay, so I graphed the center at over 2, down 3, and the radius is 4. So I went up 4, down 4, to the left 4, to the right 4. That's my boundary, and then you can just trace your circle right there, okay? So this is H, this is K, and this is R, and your equation is x minus h squared plus y minus k squared equals your radius squared. Okay, let's clean this up. This becomes y plus 3, and we'll change that to 16. And there's our circle right there. Okay, all right, write an equation of the circle with this equation. Okay, so what we have to do is group the x's together and the y's together and throw the number on the other side, so it's -30. All right, so then we take half of 10, which is 5, and square that. So 5 squared is 25, so we're going to add 25 here, and to balance out this equal sign, we've got to add 25 to that side, okay? Half of 6 is 3, 3 squared is 9, so we're going to add 9 here, and to balance it out, we're going to add 9 to that side, okay? So this becomes x minus 5 squared, this becomes y plus 3 squared. This sign is always in the middle, okay? Over here, add these up and they become +4, okay? So there's the equation, x minus 5 squared plus y plus 3 squared equals 4, okay? Notice that the center, it's not asking for that, but it could. The center is at, just think opposite, so 5, -3, and the radius is the square root of that number right there. Okay, you're going to hear my coffee beep here just a minute. So a mission control observer 8 kilometers from a launch pad observes a space shuttle ascending. Ascending is up, descending is down. Okay, the angle of elevation from the observer to the shuttle is 43 degrees. How far is the shuttle to the nearest tenth of a kilometer from the observer? Okay, so here it is right there. So here's the observer over here. He's 8 kilometers away from this launch pad right there. There's the rocket ship going up right there. There's the angle of elevation. And how far is this going away right there? Okay, there goes my coffee. All right, so is this a sine, cosine, or tangent ratio? So this is the angle. This is adjacent, hypotenuse. That would be cosine. Cosine is adjacent over hypotenuse. So find the cosine, cross multiply, divide, and we get about 10.9 kilometers away. Okay. All right, so for numbers 5 through 7, given that triangle ABC is a right angle, with the measure of angle C being our 90-degree angle, if the tangent of one of the complementary angles is given below, find the tangent of the other. And so draw the triangles. Okay, so first thing is I'm going to change these decimals to fractions. You guys remember, tangent is opposite over adjacent. Okay, opposite over adjacent, opposite leg over adjacent leg. So let's change them to fractions. So 0.25 is 1/4, 0.75 is 3/4, and 0.5 is 1/2. Okay, draw some generic triangles. Okay, and remember, opposite over adjacent equals tangent. Okay, so here we go. Look, here's the tangent of A, opposite over adjacent. So the opposite leg over the adjacent leg. Okay, the tangent of B, here's B, the opposite leg over the adjacent leg, opposite over adjacent. The tangent of B is opposite over adjacent, so opposite leg over adjacent leg. Okay, so it says, okay, we draw the triangles. We just did that, and it says the tangent is one of the complementary angles is given. Find the tangent of the other. So here we know the tangent of A is 1/4. So what's the tangent of B? It's 4 over 1. Here the tangent of B is 3/4, so the tangent of A is 4/3. Here the tangent of B is 1/2, so the tangent of A is 2 over 1, which equals 2. That's what they're talking about. So tell us the tangent of the other one, okay? All right, so we've done this problem a few times. So Brent is planning to fence his backyard. Every side of the yard except for the side along the house is to be fenced. So here's his house right there. We're going to put fencing going all the way around here, okay, except this side because we don't need a fence against the house. So if the fencing costs $4.75 per yard, how much is the fencing going to cost? Show all work. Okay, so there's our fencing right there. We're going to add those up. And so we know what JK is. JK is 13. We know what LN is. It's 23 right there. We need to use this right triangle right here, which is over here, to find this length, KL. Okay, now this is 10, because remember, the whole thing is 23, and if that's 13, that's 13, so this has to be 10 right there. So there's my right triangle. So opposite hypotenuse, this is a sine ratio, okay? So go ahead and cross multiply, and we get this length to be 18.87 yards, okay? So the total fencing needed when we add it all up is 54.87 yards. Now we multiply that at 475. It's 0 period, so you're hearing the bell getting ready to ring, okay? All right, and so sorry. So we get that's how much it's going to cost, $260.64. All right, so find the values of X. So here I'm going to let this be Y right there, and then since it's inside, we add them and take half. So when we add them and take half, we get that angle to be 115, and then we'll use this straight line right there to get 65 for X. Okay, so here's a diameter. A diameter is 180, so this must be 70 right there, okay? And this is an inscribed angle. It is half that 70. All right, so here's a circle. A circle is 360, so if we take the rest of it from 360, we find that this angle, or this arc right here, is 170 right there. Now, since this is outside, we subtract these arcs and take half, okay? So we get 55 on that. All right, so here this one is piece times piece equals piece times piece. So when you multiply those together, we get X equals 8. Here, outside, so this outside angle is 1/2 this arc minus this arc, okay? So when we do that, multiply by 2, I'm going to add x to both sides and then subtract 80 and we get 16. Okay, here, outer times whole, outer times whole. The whole is x plus 4, the whole is 12, okay? So outer times whole, distribute through, subtract 60 because it's a quadratic equation. We want them to equal 0 so we can factor them and then set the factors equal to 0, and then we get x equals 6. It can't be a negative length right there, so it's just x equals 6 right there. Okay, almost done. Alright, so outer times whole, so the whole is 15. The whole on this one is x plus 5 equals outer times whole. Okay, so distribute and subtract 13. Okay, so outer times whole, which is 5 plus x, equals the tangent segment squared. Okay, so distribute, subtract 25, divide, and we get 24/5. All right, you guys, take care.